All right, everybody, we are going to dive into a soil test report today. So this is Petro, and I wanted to go through a soil test. I will throw out some caveats. This is going to apply to Western Ohio, Eastern Indiana. As you get outside of that region, you're going to see some different potentially tests, especially in phosphorus. You're going to see different ranges of things, and this is going to be mostly for corn, soybeans, wheat. Not going to really get into soil fertility for forages or other crops like that. So let's dive in. And this is a report from A&L Labs. You're going to see a lot of similar things in reports from different labs. I've worked with quite a few. Never really been unhappy with anybody. Just A&L is the one that I've worked with the most lately. And a couple of things. We're going to see a sample ID. So whatever you submit this sample as, so if you were to pull a sample from your home by the barn, you might call it home barn 1. That will show up on the report here. Then you'll see the lab number. That's their internal number for it. And then we get into all of our great fertility information that we'll break down here fairly quickly for this report. And then we'll have some other reports where we're comparing information. One thing I do want to note, with most labs you'll see HML, so this is high, medium, low. These are based off of fertility recommendations. So as we look at these numbers, if they get too low, you're going to get to a critical level. So that is where the soil is deficient in a certain nutrient and it's not able to supply enough to a plant to consistently produce yield. So that doesn't mean that if you're critically low in something, you can't produce high yield. Your chances of doing that are a lot lower. So we'll start out here with organic matter. So this is the organic portion of what's in the soil. You can see here we are at 3.4. That's pretty good. It's not going to be your best soil. It's not going to be your worst soil. This is a Hoytville silty clay loam, and we'll talk about a few things that can point you in that direction on here, but those tend to range in that 3 to 4% organic matter. In a good year, this is a 200 bushel per acre plus field of corn. In a bad year, it's 150 to 170. So 3.4% organic matter. That tells you the ability of the soil to supply certain nutrients that come from that organic fraction, like nitrogen, like sulfur. As you get down into that 2 to 1 range, that's very low. As you get up into that 25-30%, you're looking at a mostly organic soil, so like a muck soil, really high organic matter sand. And we'll move over to the right here. We've got our phosphorus, and you can see here we're looking at Bray 1 and Bray 2. So the Bray test is for slightly acidic soils. If you're out west in Colorado, Kansas, anywhere where you've got a really high, where you've got a high pH soil, you might be looking at a different test. But for Ohio and Indiana, we mostly use Bray 1 or Bray 2. So Bray 1 looks at how much phosphorus is available in the soil right away. Now, if we dive back into our soil phosphorus that we learned about in school, we know that there is an available form, there is a labile and a non-labile. So the labile is available, but it's basically in storage, is the best way to think about it. So you've got your reservoir, which is what Bray 1 looks at. That is the amount that's currently available to the plant. The Bray 2 includes portions of that labile fraction that as we pull from that solution, we're going to get some from that reserve. So you'll see a higher number. We'll look at that in a minute on the Bray 2 than you do on the Bray 1. That's because it's looking at both the available and the reserve. Potassium level. This is going to give us an idea of where we're at on potassium. When we look at making a recommendation off of this number, it also includes CEC. So CEC is our cation exchange capacity over here to the right. That gives us an idea of the amount of binding sites available for our cations, like potassium, calcium, magnesium, hydrogen. So this is an important fraction. It tells us how much we can hold of those cations. It doesn't necessarily tell us how much we can hold of our negative portions of the soil, like sulfur in the sulfate form, nitrogen in the nitrate form, but the higher the CEC, typically the better a chance we have of holding on to things like nitrate and sulfate. As we're going through magnesium, calcium, these I don't spend a lot of time looking at in our region. They might help us pick a liming source, and there's a lot of discussion around, do we need to maintain a certain ratio of calcium to magnesium? For corn, soybeans, and wheat in Ohio and Indiana, I don't look at the ratio of the two. I just make sure that there's enough magnesium, enough calcium. If we have a really, really high magnesium number and we have an average calcium, I might pick a calcitic lime, which is not going to have very much magnesium in it because we don't need more magnesium in the soil. If this were an L, we were low in magnesium, I'd go for a dolomitic lime. But generally, I don't spend a lot of time on magnesium and calcium or the ratio of the two outside of that lime selection. Some folks will definitely argue that when it comes to different soil types, when it comes to forage crops, that may be something different, but I don't really worry about the ratio. It's more, do we have enough of each? So we'll keep moving down the line. So soil pH and buffer pH. Soil pH is the pH of the soil. We want to be in that 6.0 to 6.5 range for the most part. The wide range, you could be 6.0 to 7.0. It would not necessarily be a problem. But as long as we're in 6.0 to 6.5, we're happy. Most of our soils are acidic. So that's where we look at a lime recommendation. That lime recommendation is going to utilize this buffer pH. So this takes into account how much lime we're going to need to apply in order to change the pH of that soil. So if we have a low CEC soil, we don't have a lot of binding sites for this hydrogen portion. That hydrogen is going to be pretty well in solution and available for that calcium carbonate to interact with in order to change that pH. So with a low CEC, we don't need a lot of lime to move that soil pH up. If we're in a soil with a high CEC, there's a lot more buffering capacity. So those extra cation exchange capacity sites can hold on to hydrogen. So if we put in our calcium carbonate that we're going to use to lime, it will interact with the hydrogen that's in solution, and kind of like we talked about with our phosphorus, some of that will come out of solution. That hydrogen will come out of solution and then interact with that calcium carbonate. So the higher the CEC, the more buffering capacity, the more lime we're going to need. This percent cation saturation, you might see it as base saturation. We don't really utilize this at all except for comparing soils. I don't want to spend a lot of time on this. We'll talk about it in later videos. So we'll jump down here to the bottom. And what I will say about this whole line, sulfur, zinc, manganese, iron, copper, boron, our soil tests are not very good for indicating what we need when it comes to sulfur and micronutrients. So sulfur, this test only tells us what is currently available in the soil. Organic matter is our #1 source of sulfur in our soil outside of our own fertilizer. So if we are pulling a sample in the fall, that's not going to give us any indication of what sulfur is going to be available in the summer. So I don't put a lot of emphasis on this sulfur test. So if we're in season pulling a soil sample for a pre-side dress nitrogen test, I would look at the sulfur there because that's going to give us an idea of what's available. If it's a fall or spring soil sample, I'm not going to pay attention to sulfur. And the test for zinc, manganese, iron, copper, boron, they're not very accurate. So I'm going to look at our organic matter. That will help us figure out what is going to be available. If we get really high organic matter, we can tie up things like manganese. We get low organic matter, we can lack the ability to supply, or we might bind up certain micronutrients. So I don't spend a lot of time on these. What I like to do for sulfur and micros is do an in-season tissue test. So that's the basics of a soil test report. I'll have a few more videos where I do a deep dive into looking at soil test reports, making recommendations, and all of that fun stuff. So thank you for watching. Have any questions, just send them along.